Hello and welcome. In today's video, we're going to be talking about an issue that has been troubling a lot of people in the Fabric ecosphere, specifically the one related to SQL endpoint delay in Lakehouse. So if you go on Reddit or if you go to the community forum for Power BI and Fabric, you will find a bunch of different posts where people are complaining that they ran a notebook, they loaded data into the Lakehouse, then they went into the SQL endpoint, they ran a query and the tables are not there, or for whatever reason data does not show up. So I had a chance to talk to my friends at Microsoft, talk to a bunch of folks to try to figure out how to deal with this, because it seems to be a major pain point for a lot of people. So today's video will be about giving you some options on how to understand what's happening and how you might force manual synchronization between the Lakehouse and the SQL Analytics Endpoint. Before we jump in, a quick housekeeping announcement. So last couple of weeks, I was in heavy travel and Nikhil was in heavy travel, so we did not get a chance to post on a regular basis. I know some people sent me notes, what's going on, everything's fine, everything is good. We're going to get back on our regular schedule again. So it was just a temporary hiccup. Unfortunately, we just got super busy, didn't get a chance to queue up a bunch of videos for you guys. So from now on, the videos will start coming out again every Tuesday, and every now and then there's going to be another one on Thursday. Anyway, let's jump in and see what we can do to address this SQL endpoint delay in Lakehouse issue. Before I go through my code, and by the way, everything that you're going to be seeing in this video, if you go to the description of this video, there will be links posted to original posts and also to the notebook on our website that you can download and play with all the code yourself. So before I get too far in the video, I got to give the credit where it's due. So Mark Price Maher wrote this post where he goes out of his way to make sure that this is absolutely positively not supported by Microsoft. And he talks about, he basically makes this script available on how to force manual synchronization between the Lakehouse and the SQL Analytics Endpoint. Also, there is a GitHub repository that you could connect to and download his code. His code, however, is not super robust. I don't think it's meant, obviously, to be robust. It's basically was developed just to give us some ideas on what we might be able to do, and it's exposing some of the undocumented API that we could try to use if we are absolutely stuck and we're trying to make some progress. And that's we've reached the point of last resort. We've tried everything else, nothing works. So you may want to try this approach to see if that gets you where you need to be. So again, all the links will be in the description of this video. So now let's jump into our situation. So here I have a Lakehouse, and in my Lakehouse I have a bunch of different tables. And what I will do is, unfortunately, this issue is not that, or fortunately actually, this issue is not that common. So about a year ago, it was actually quite common, where we would write something into the Lakehouse, then go to SMS, run a select statement, and data is not there, table is not there, a bunch of different issues. But over the last, I would say, 3-4 months, the quality has improved dramatically, and now we almost never see this issue. However, because there's so many people are using Fabric, every now and then this issue does occur. So even though I can't replicate it myself, I'm going to try to come up with some scenarios that I know will break it, so that we could test this approach. So let's see how we're going to be addressing it. So the idea here is that we're going to write a function, and that function, so here the function name is run sync, and that function will basically force or trigger the metadata synchronization job. So what happens when you write data into the Lakehouse, that data does not get available in SQL endpoint right away, because basically something needs to happen to go through all of the Parquet files, catalog them, and then do whatever needs to happen before they show up in SQL Analytics Endpoint. However, sometimes those files don't show up, and they don't show up. Again, it's a kind of a sensitive topic, but basically what happens, there may be an issue that's related to the synchronization process. Normally it's supposed to synchronize things within a couple of seconds, but sometimes some customers report that it takes minutes or tens of minutes before data gets synchronized. Usually, I'm guessing, but I'm doing an educated guess here. It's related if you have just a huge amount of files, small files, if you're using some interesting partitioning schemes and other things. So basically, in some scenarios, there may be some internal bugs or some internal inefficiencies that slow down the synchronization process. So we're going to have an API call in this code to force the metadata synchronization. Another problem is that sometimes the job does run on schedule, but some files look okay from the Spark perspective. But when you look at what's happening in the SQL Analytics Endpoint, SQL Analytics Endpoint has certain restrictions that make the files okay for Spark SQL and not okay for SQL Analytics Endpoint. And that sometimes is an issue. So we will try to see how we can force some of these issues and then see if our code here, our script here, can actually help us troubleshoot. So again, this is in no way, shape, or form production quality code. I try to make it a little bit more robust relative to how Mark developed it. So I made it a little bit more robust, but again, all the usual caveats apply. No support, don't do this. This should be your last resort, but you could try it. I've tried it pretty successfully, and it was actually very educational to just go through this to understand how some of the internal things in Fabric work. So let's just go through this code here and see how it works, and I'll just explain the logic behind this approach. First of all, we're going to import a bunch of things. I'm not going to spend too much time on this, but the good news is I didn't have to install anything. Basically, I just did imports. Looks like all the stuff is part of the standard Fabric runtime. You're going to have your own logging mechanism, sure, to make it more production ready. I just implemented some basic logging here. And I've implemented a couple of helper functions just to make my code a little bit more robust. I happen to be in the Eastern time zone this week, so I customized my code to make it run and display all of the times in US Eastern time zone. So that's what this function does. Also, I made it a little bit more robust so that added some error handling. So if I'm adding something that's not a time, then return an A. And now we're gonna go through code. So basically, the heart of the code is here, sync-SQL endpoint. So we will look at this function a little bit further, but let's see what we have to do to get to this point. Right? So we implement the function that does the SQL endpoint, but before we run it, we need to pass a couple of things to it. So it needs a client, and that is the Fabric REST client. That comes from Fabric object, and that comes from here. So we're using semantic link. Okay, so as long as you have semantic link, which is now bundled with the default notebook runtime environment, we're good. So we're gonna have our client, and then we're gonna get a couple of other things. So we need to have the workspace ID, and we need to have the Lakehouse ID. So our sync SQL endpoint function needs a client, which comes from semantic link. Then we're gonna query workspace and Lakehouse, and then what we're gonna do is we're gonna create a new table. So here I drop a table if it exists, and I create it right away. And then I'm gonna run my sync function in order to force that metadata synchronization job from Spark environment into SQL endpoint. So now that I have my client workspace ID and Lakehouse ID, we could try to go through this code and see how everything works. So the first thing that we need to do is so what's cool about this client object is we can call on get and post methods on it, and all we need to do is just to pass the URI. So we're saying, hey, give me the we're passing this information. So we're saying for this workspace in this lakehouse, call the get function and then return it into a JSON. And then from here, we're going to get the JSON written into the lakehouse info. And then from this JSON, we're going to go to properties and get the ID of the SQL endpoint. So when we're in this line, we found our lakehouse in our workspace. We called on the get method from the REST API, and now we're getting the SQL endpoint ID. So that's an important piece of information because we're going to be synchronizing that endpoint ID, right? So then, before we call on our synchronization function, so synchronization function, the synchronization call has kind of two parameters. We need to say, hey, which SQL endpoint are we going to be synchronizing? And that's going to be living in this URI. And then we need to send it the actual command. So in this case, command lives in this variable called payload. And we're saying, hey, run this command through the post, right? So HTTP post, and pass it this information. So basically call pass this parameter called metadata refresh command. So it's calling on undocumented API, and it's calling, for the lack of a better word on this call, metadata refresh command, and it's doing it on our SQL endpoint. Once that's run, we're going to check if that call was successful, and if it is, we're going to now start looking at, process it further. So what happened was, once we got the response and the response was not a failure, now we can read from the response, and what's important for us is to get this batch ID. So basically it looks like what happens, thank you. What happens is we do our post, right? So we do our post on our on this URI and our SQL endpoint, and then it starts a batch, right? So this batch runs, and then we can check that batch. So it creates another URL or URI, and we can check that URI to see whether the batch is still running. So every time we call on this, so when we make that call, which is called here, right? So we do a get on this link, on this URI, it's going to return a status. So when the status is in progress, that means it's still running. So because I might have a lot of different tables, so as long as the batch is still running, it's going to return in progress. Then if it ends successfully, it will return success. And then otherwise, if it fails for whatever reason, it returns failure, right? So now what we're going to do is, so basically what happens, we run this batch, and then in the loop, we're checking the status of this batch. And as long as it's in progress, we just keep waiting, right? So we're going to keep waiting. We're going to keep checking. And then, so we're sleeping for 1 second. And then we're going to wake up and say, okay, well, are you still running? Let's check what the status is. And then if it's successful, let's say I'm done. Then what's going to do is, as part of the response here, we're going to get this object that has information it has a JSON object, list of all of the tables. And for each table, it gives me the table name, tells me when it was last successfully updated, whether we successfully updated it now, and then what state it is. Was it synced or not synced? So basically, from what I understand, kind of trying to make sense of this API call, the way this works is it doesn't force the metadata synchronization. It only synchronizes things that do need to be synchronized. So for example, if I had a table and that table got synced into SQL endpoint, 10 minutes went by and I run this job again, it's smart enough to say, hey, it's already in sync, don't sync it again. So it's basically being a little bit more efficient. And when that happens, if the table does not need to be synchronized, then it will tell me that synchronization did not occur, but that's not an error. That just means that table between Spark and in SQL endpoint environment, those two are already in sync. So when I run this and we look at the output, we could see what the difference is, right? So basically, if it's successful, we're going to display kind of what happened. Then we're going to check on failures, and then if we do have an error, then we will see what happened with an error, and that's about it. So we ran it before, and what we see is, let's look at the output. The output is the following. So I have a bunch of tables here, and you could see these are all the tables that's set there for a while. And it says that, hey, for example, table product, last time I updated it was September 10th of 2024. So I have not touched this table, I have not updated it, I have not done anything with this table. So it says, hey, I did not run the sync on this, didn't do anything with this, and last time this table was updated in September. And you could see that these dates will differ for different tables, but the one that we created here, test 1, so this is the test 1 table here, it says last update not available, which is interesting because it just got updated, and then sync state is success. So what that means is it actually did run sync on this table and it was successful. On everything else, you see how it says did not run, not run. That means that it did not have to update those tables. So now my thing expired. Let me run this again to wake it up. And then let me explain to you what we're gonna do. So here, when this cell runs, we are creating a new table and then we're forcing the sync on it. So let's give it a few seconds to finish running, and let's run the sync next time without having created a new table. Okay, so I just reran it. It looks exactly like the last time. But now what we're gonna do is, so I had created this table, and when I run sync, I wanted to sync that table back into SQL Endpoint. Let's run it again now that the table is already there and we didn't do anything to it. So see here it says last update NA, sync state success. Now I'm just gonna run sync again and it comes back much faster. And now it says, hey, table test 1, last update now, instead of saying NA, now it says it was actually done at 6 o'clock. So I'm doing it on Sunday, right? So 6:02, right now it's 6:03. So that's from the prior run. And then state is not run. So this is pretty useful. You can run this script already and use it for some kind of debugging to say, okay, does this table need to be synced? Does not need to be synced? When it was synced last time? So right of the gate, it's already somewhat more useful because you're starting to understand exactly what's happening between your Spark and SQL endpoint. Now let's break it. Let's create a use case that we know will not synchronize properly into the SQL endpoint and see how our script handles that. The way we're going to do this is we're going to drop our table for test 1, create it, and then we're going to create another test 1, but now with an uppercase T, right? So we're going to, because Spark is case insensitive, so when I run this, well, joys of doing videos. This literally was working, my test code literally was working about an hour ago. Something must have been released into Fabric to prevent this test case, and now I can't use this anymore. But basically what it used to do, it created two tables, one test 1 with a lowercase, one test 1 with an uppercase, which was used to be able to do like an hour ago in Lakehouse and Spark. But then if you go to endpoint, this scenario would not be supported and it would be complaining and saying, hey, you gotta go fix this. And then what it used to do, it would actually give me a really nice error saying, hey, table test and test 1, they have different uppercase and lowercase t, so you need to fix it. So the code here will take care of it. It'll show you what the error is. Unfortunately, I cannot show you right now in this video. What we can do also is use another scenario. So let's see if this one works. So I was trying to find a bunch of different tables that would possibly break it. So here's a scenario where I created a table that has some unsupported data types. So I'm going to run this. So this creates a table. And as you see, it's using array type, a map type, data types as it creates this table. So this table you will be able to query from Spark, okay? So it'll come back with something. So you see it comes back, but now if I run my synchronization job, and if I switch to the SQL Analytics Endpoint, so this table here says, hey, I'm not super happy. There's a couple of column types that are not supported. So this output here just says, hey, it was synchronized, which it was. If you want to see the warning, what you will need to do is you will need to actually explore this entire object. So let me go ahead and make a couple of changes to this code so we could see everything in the JSON this returns and see if there's any warnings. Okay, so now we're going to get into the weeds a little bit. So what I did was, once we call on our batch status, we can then look at the JSON of what it returns. So here, I'm just displaying this so we can examine what's happening for each table. So at first, it returned all the usual output. You saw this before. But then what happens is actually in that JSON object, there is a ton of cool stuff. So basically for every table, it tells me what the table name, synchronization, when it was started, when it was ended, whether there's an error, if there is any corrective action. So anytime that you run this sync job and it fails, then you could take a look at this object and examine it for any kind of insight as to what might be causing this issue. So here for our table unsupported data types test, it says, hey, there is a warning. Columns of the specified data types are not supported. So basically it's going to go through all the tables into your lakehouse that it's going to try to sync, and then it's going to output either an error that is causing the synchronization or a warning. So in this case, it did synchronize this table, it just couldn't synchronize some of the columns with those unsupported data types. So this took a little bit longer than I expected to get through. There was a couple of hiccups, I'm sorry, but this is the life in a big city. So again, just wanted to say thank you to Mark for writing this brave, albeit unsupported and undocumented and frankly unwise post. So all I did was just to make it a little bit more robust, and I went through this in this video to help you guys understand how we're going to calling an undocumented API within Microsoft Fabric and what tools we might have to try to understand why our Delta Parquet files, why our Spark tables do not show up in the SQL Analytics Endpoint. Again, all the links and every resource mentioned in this video, I will have those links in the description to this video. Thank you so much for stopping by, and I will see you soon on the next one.